Welcome to Shanti-Peace for Mathematics. Let us recall what we did in the previous lecture. So in the previous lecture, we have talked about a successive differentiation of the function y is equal to e power ax, that is yn is a power n e power ax. The second function we have discussed that e power mx, then the nth derivative of a power mx is m power n log of a power n a power mx. And the last one we have discussed is sine ax plus b. The nth derivative of the sine is sine ax plus b plus n pi by 2 into a power n. And I have given you as an exercise that instead of sine, if you use cos here, then you will have cos on the other side. Now in this lecture, we'll discuss the nth derivative of a function y equal to ax plus b power m. That is a polynomial function. As we know that the first derivative of x raised to n is n x power n minus 1. So here the first derivative of this one is m ax plus b power m minus 1, and then by chain rule the derivative of ax plus b is a. If you take the second derivative, then you will have m into m minus 1 ax plus b power m minus 2. And if you take this again derivative of ax plus b, then we will have a square. And if you go in that further, we need to find out what should be the formula for yn, nth derivative of that. So as you can observe that when is the first derivative, it is m, second derivative is m minus 1. So the terms which we have, and this a square, so this first term a power n is already there. Then it is m minus 1, m minus 2 up to m minus n minus 1 should come, and into ax plus b power m minus, you can see that if it is the first derivative, then it is 1, second derivative, then it is 2, so it is nth derivative, so it should be m minus n, where your m I have considered it is any real number. So ultimately what is the statement we can make out from this is, if you have y which is ax plus b power m, where m belongs to R and a and b also belongs to R, then yn is a power n m minus 1 m minus 2 up to m minus n plus 1 ax plus b power m minus 1 n. So we shall prove this results using mathematical induction. So we shall prove the result using PMI. Let us recall what is the PMI. So Pn is a statement which is we want to prove for any natural number n. Then you have to follow the 3 steps. The first one is to check whether the result is true for n equal to 1. Second step is to assume the result is true for n equal to k. The third step is to prove the result is true for k plus 1. And if you follow this 3 steps and it is satisfies, all the conditions will satisfy, then we can say that the given equation Pn is true for any natural number n. So here we have to consider the statement Pn is yn, it is a power n, m minus 1 up to m minus n plus 1 ax plus b power m minus n, where y equal to ax plus b power m for any n belongs to n. Here what we have given, it is y equal to ax plus b power m. Since I want to prove the result is true for n equal to 1 for the step number 1 of PMI, principle of mathematical induction, we'll take the derivative. So taking derivative both sides with respect to x, we get y1 is equal to m into ax plus b power m minus 1 into a d by dx of ax plus b using the chain rule. So this will give you a into m into ax plus b power m minus 1. So hence what we can say is that therefore the statement P1 is true. That you can see due to this, if n equal to 1, this is a power 1, and if n is 1, it will have only m is there. So we have that also here, and it is m minus 1. Now we have to assume the result is true for k. So assume that the statement Pk is true for all k belongs to n and for k less than n. That means yk is equal to a power k m minus 1 m minus 2 up to m minus k plus 1 ax plus b power m minus k. Since I want to prove for the result for k plus 1, I need to have what is k plus 1th derivative. So for that I can taking a derivative both sides with respect to x, we get yk plus 1, that is d by dx of yk. That is the derivative of this quantity. But this quantity is independent of x. So I can write down that is outside m into m minus 1 up to m minus k plus 1 into d by dx of ax plus b power m minus k. So therefore yk plus 1 is equal to a power k m minus 1 up to m minus n plus 1 k minus k plus 1. Then the derivative of ax plus b power m minus k will gives you m minus k into ax plus b power m minus k minus 1. This can be rewrite into the form of a power k plus 1 m into m minus 1 up to m minus k plus 1 is as it is, and this m minus k I can rewrite as m minus k plus 1 minus 1. So I've added 1 and subtracted 1 from this. So it is minus k plus 1. Okay, and ax plus b, here also I am taking m common, minus sign is common from this k and 1, so that's why it is k plus 1. Now you can observe that in the previously yn statement we have is whenever n we have here, in this we have k plus 1. So therefore I can say the statement pk plus 1 is true. Therefore by PMI the result is true for any n belongs to n. So hence what we can say is, if y is equal to ax plus b power m, then yn is a power n m minus 1 m minus 2 up to m minus n plus 1 ax plus b power m minus n. If m is an any real number, then we can express in this fashion. But what will happen if m is a positive integer? Positive integer means it is a natural number. Then what is the nth derivative of y? Then in that case, I can talk about the factorial, m factorial. So yn, in this case we have a power n as it is. What I will do is I am multiplying and dividing some terms here. So in the m minus 1, m minus 2 up to m minus n plus 1 terms are already there. So I am just multiplying further more terms, that is m minus n minus 1 up to 1, and I am dividing these terms, that is m minus n minus 1 up to 1. So ultimately what we have did is we have multiplied this term and divide that, and into that ax power m minus n is already there. Now what is this numerator here? That we can say that it is 1 into 2 into up to m. So the numerator is actually m factorial, and in the denominator what we have, it is actually 1 into 2 into up to m minus n. So it is m minus n factorial. So ultimately what we got from this is yn is a power n m factorial upon m minus n factorial ax plus b power m minus n if m is bigger than n. If m is bigger than n and m is a positive integer, then we have, this is the nth derivative. What will happen if m equal to n? That means it is equal to n. For example, if I have given you y is equal to x power 10, then what will be the y10? So if m equal to n, according to this, I can say it is a constant term, because if n equal to n, you can say that yn is this. Yn is a power n m minus 1 up to m minus n plus 1 ax plus b power m minus n. Now with this, m is equal to n. So this will give me n this will gives me n, this is gives me n, but this n will get cancelled out. So we'll have 1 here. So we'll have ultimately a power n into n minus 1, n minus 2 up to 1. And this m is also n. So n minus n, ax plus b power 0 is there. So ultimately what we get is a power n into n factorial. If m equal to n, then it is n factorial into a power n. And the next question I can ask you, if the nth derivative, that is the 10th derivative of for this function is 10 factorial according to this, then what will be the 11th derivative? And since this is a constant, the 11th derivative is 0. So ultimately, if your m is a positive integer, if m is bigger than n, then the derivative is this. If it is equal to n, then the derivative is this. And if m is smaller than the number of derivatives, then the derivative is 0. So finally we conclude that if y is equal to ax plus b power m and m is belongs to n, then yn will be divided into 3 parts. The first one is, it is m factorial upon m minus n factorial a power n ax plus b power m minus n if m is bigger than n. It is a power n into n factorial if it is m is same as n, and it is 0 if m is smaller than n. This is the first things we can conclude, that nth derivative of such function is look like this if n is a positive integer. Now from this we can also derive one more formula, two more formula from this. The first one is, what will happen if m equal to minus 1? If y is equal to ax plus b power m, then we know that yn is a power n m minus 1 up to m minus n plus 1 ax plus b power m minus n. If n equal to minus 1, then you can say that a power n, this is minus 1, m minus 1 will become minus 2, the next term will be minus 3, up to so on. This is minus 1, so minus 1 plus 1 will cancel out and will have the minus n. This is ax plus b power minus 1 minus n. How many times here minus is there? We can say it is n times, so that is a power n into minus 1 raised to n. And the left quantity is 1 into 2 into 3 up to n, so it is n factorial. And this ax plus b I can write down in the denominator ax plus b power n plus 1. So the corollary of the previous result which we can say here is, if y equal to 1 upon ax plus b, then yn is minus 1 raised to n into n factorial into a power n upon ax plus b power n plus 1. From this, one of the more corollary we can write is, if y equal to a log ax plus b, then the question is, what will be the yn? And the yn we can get from this corollary that we have discussed just now, because we know that the derivative of y is 1 by ax plus b is log ax plus b. If y is equal to log ax plus b, then we know that the first derivative of y, 1 is 1 upon ax plus b into a. And the nth derivative of y, if it is 1 upon ax plus b, then we have a formula like this. This is the first derivative. So if I take the nth derivative both sides, taking nth derivative both sides, we get yn plus 1. Because the first derivative is already done, this is the nth derivative we have to calculate, and there a is constant, so I can say it is d nth derivative of 1 upon ax plus b. And the nth derivative of 1 upon ax plus b we have calculated like this, so that's why it is a minus 1 raised to n into n factorial a power n upon ax plus b power n plus 1. So if I can reply or simplify this, this is minus 1 raised to n into n factorial a power n plus 1 upon ax plus b power n plus 1. This is yn plus 1. So if I want that yn from this is n plus 1 the derivative. So if I want yn derivative, you have to replace n plus 1 by n, or I can say n by n minus 1 in this. So whenever you see n, you just replace n minus 1, will gives you a formula for nth derivative of log ax plus b. So if y is equal to log ax plus b, then yn will be minus 1 raised to, whenever n is there, I will replace n minus 1. So it is n minus 1 factorial, because it is n factorial, then it is a power n plus 1, but instead of n plus 1 we have to replace n, so it is a power n upon ax plus b power n. So let us recall what we did in this lecture. We have derived the few formulas for nth derivative successive differentiation of ax plus b power m. If m belongs to any real number, then yn you can write down is an m into m minus 1 up to m minus n plus 1 ax plus b power m minus n. If m is a natural number, then yn you can write down as m factorial upon m minus n factorial a power n ax plus b power m minus n if m is bigger than n. It is a power n into n factorial if it is m equal to n, 0 if m is less than n. The second task we have did is if y equal to 1 upon ax plus b, then yn is minus 1 raised to n factorial a power n upon ax plus b power n plus 1. And the last one we have did is y is log ax plus b, then yn is minus 1 raised to n minus 1 factorial a power n upon ax plus b power n. That's it for this video. If you like this video, please press the like button. If you have any comment, suggestion or question, please drop down in the comment box below. See you in next video. Till then, bye bye, sayonara.